So far we have looked at an arithmetic series as well as a quadratic series. Now let's go and see what a geometric series looks like. Now we are given the following series, and at first glance we cannot really determine what kind of series it is. So we have to go and test for it first. So we will first start to see if it has a first constant difference. So 6 minus 3 is 3, 12 minus 6 is 6, 24 minus 12 is 12, 48 minus 24 is 24. So as you can see, these answers are not the same. So it is not a first constant difference, and this is not an arithmetic series. So we continue to the second step. 6 minus 3 is 3, 12 minus 6 is 6, and we can stop right there because this is not a second constant difference, so this is not a quadratic series. Well, now we have to go and test to see if it is a geometric series. Now, how do we do that? Now, let's go and see. We will say 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is 2. 48 divided by 24 is 2. So can you see, when we divide consecutive terms with one another, we get the same answer. Now this answer that is the same when we divide consecutive terms is called a common ratio. When we have a common ratio, this series is a geometric series. Okay, so a geometric series has a common ratio, and that is when we divide consecutive terms. That basically means that when we take term 2 and we divide it with term 1, we get the same answer as if we took term 3 divided by term 2. It will be the same answer if we take term 4 divided by term 3, and it will give us the same answer if we took term 5 divided by term 4, because a geometric series has a common ratio. Now, the general formula of a geometric series looks like this. Well, the term in the nth position is equal to a times r to the power of n minus 1. Now, what we would like to do is find the numerical value for a as well as r. Well, a is the first term in the series. It is term 1. That is what a is. And r is the common ratio. Now let's go and look at an example and how we can determine the general formula. Now we are given the following geometric series. Because we know it is a geometric series, we know that it has a common ratio. So 6 divided by 3 is 2, 12 divided by 6 is 2, 24 divided by 12 is 2, and so on. So a geometric series has a common ratio. Now we simply write down our general formula, which is the term in the nth position is equal to a times r to the power of n minus 1. Now we do simple substitution. In the place of a, we put term 1, which is a 3. There we go. And in the place of r, we put the common ratio, because r is the common ratio. So the 2 goes into the place of r. And there we go. So the term in the nth position is equal to 3 times 2 to the power of n minus 1. And we leave it just like this. We cannot multiply these two bases because we can only multiply bases when they are exactly the same, when they have exponents, right? You remember that. Now in the next lesson, we will see how we can use this general formula to determine a term as well as in which position it might be. See you next time. Bye.